Let's look at our next problem where we're given 3 parts of a triangle and asked to determine the remaining 3 parts. 2 sides and an angle are given below. Determine whether the given information results in 1 triangle, 2 triangle, or no triangle. So they sort of tell you up here that this is that case where you don't quite know for sure what you're going to have until you actually start solving the problem. So let me quickly review how I like to think about this. If you watched my video lecture, here's how I approach when you have an angle side-side triangle. There are actually 2 different kinds of triangles, and whichever one you have is going to determine which path you go down to solve it. Now this is just what I do because it helps me, and if it helps you, great. This didn't come from the book. The 2 possibilities, I like to think of it as matching and non-matching. Just so you know, when I do things like this, I'm trying to think of the simplest, easiest thing to remember to know what I need to do. So matching means that the angle and side have the same letter. In other words, you might have angle A and side A, or angle B and side B and side C. In other words, whatever your angle is, you also will know the side opposite that angle. I like to think of it as matching because it's so easy to remember. And just so you know, in a minute we're going to see if we have matching, then we need to use the law of sines. Non-matching, I should give an example of matching. Well, I think the problem we just discussed is a matching problem. Because look, my angle's A, we have side A and side B. So for the problem we're going to do in a minute, they told me 30-degree angle A, side A is a length of 5, and side B is a length of 3. I call this matching, angle A and side A. So in a minute, we're going to solve this using law of sines. If it's non-matching, then you end up using law of cosines, and we will do one of these in a little bit. Now, the tricky thing is, if you have matching law of sines, here's where you have 3 possible outcomes, and that's what the question was referring to. Sometimes it turns out with the information you're given, it actually you cannot form a triangle with that information. So we say there's no angle. Then other times, when you start doing the work, you find out that there's actually 1 triangle that has this information as a part of it. But then sometimes there are cases where there are actually 2 possible triangles where all these things are true. And we don't know what's going to go on until we start. So in a minute, we're going to solve this problem using law of sines, and we're going to see what happens. So let's go and do it. So let's make this clear. So this one is angle A is 30 degrees, side A is 5, side B is 3. So the things we have to determine, we have to figure out angle B angle C and side C. Since this is matching, I can use the law of sines. In this case, I know angle A, side A, and side B. I can use the law of sines to find angle B. So my law of sines is going to be the sine of A over A equals the sine of B over side B. Now if I fill in everything I know, angle A is 30. Sine of 30 degrees. Side A is 5. I do not know angle B. And then side B is 3. So the only thing in here I don't know is sine of B. Let's just cross multiply again. I'll have 5 times the sine of B equals 3 times the sine of 30 degrees. And if I solve for the sine of B, because I'm trying to figure out angle B, it's going to be 3 over 5 times the sine. Let's just go ahead, I'll grab my calculator and do this calculation. Once again, make sure you're in the degree mode. 30 sine times 3 divided by 5. Now, I guess I don't have to round off because it actually is 0.3. That makes it easy. So the sine of B is 0.3. What I really want to get is B. How do I get from the sine of B to B? Take the inverse sine of both sides. The inverse sine of the sine of B is just B. So now, you go to your calculator, put in 0.3, although 0.3 is already here. Now I'm going to hit my inverse sine key. And this is now angle B. Now if I look at the instructions, I think it said type an integer or decimal rounded to 2 decimal places. So once again, 2 decimal places. So looks like 17.457. 7's the third digit. That causes the 5 to bump up to a 6. Looks like 17.46 degrees. So what I'm going to do now, I'm going to go ahead and finish this triangle. So this will be hopefully my first triangle. Let me keep track of things over here. So I don't know if I've got 1 triangle, 2 triangles, or no triangle, but let me keep track of what I have so far. I'll call this the first triangle. 17.46 degrees. Now, I can go ahead and find the angle C, because if I know angle A and now I know angle B, I can find C, right? By saying, adding the 3 angles together. Angle A is 30 degrees, angle B 17.46 degrees, and here's angle C. So it looks like, I'm using my calculator for this. I can add these together. This is 47.46, and then I'm going to subtract it from both sides. So 180 degrees minus 47.46. 132.54 degrees. So now I've determined for this triangle, angle C is 132.54 degrees. The only thing that's left is side C. To side C, I can use the law of sines with either angle A or B. I'll use it with angle A. So sine of A over side A equals sine of C over side C. If I plug in everything I know, angle A is 30 degrees. Side A is a length of 5. Side C is 132.54 degrees over side C. If I cross multiply, C times sine of 30 degrees equals 5 times the sine of 132.54 degrees. Let me see if I can finish this on this sheet of paper. So C is going to be 5 times the sine of 132.54 degrees over the sine of 30 degrees. So I got my calculator. The sine of 132.54 divided by the sine of 30. And you multiply that by 5. So I get 7.368. So 7.37. So now I have the information for the first triangle. So of the possibilities, I know it's the no angle is not applied. So I've got one angle, but now the question is there a second triangle? We have to go check. We have to actually do some more work. And after we do one more step, then we will know whether we have two triangles or not. So here's what you do. Once again, I taught about this, so I'm not going to teach a lot about it, but I'm just going to do it. For this problem, the very first thing we did was we found angle B. It was right here. That's the very first thing we did, the only thing we could do. If there is a second triangle, so let me put here, check second. So the initial angle B for the first triangle if there is a second triangle, now here's what I do. For the second triangle, for the dimensions that are different, I put a little tick mark. So if there is a second triangle, this is going to be what the new angle B is. And the new angle B is I take 180 degrees and I subtract angle B from the first triangle. So I take the angle B from the first triangle, I subtract it from 180. I'm going to do this on my calculator. 180 minus 17.46. So here's what this says. If there is, we don't know if there is or not, if there is a second triangle, the new angle B will be 162.54. So here's what I know. Since the three triangles, if there is a second triangle, have to equal 180. If I add the three angles together, now angle C, the information we originally given, that's going to be the same information if there is a second triangle. For the second triangle, the only things that are going to change are what we're trying to find here. So angle A, 30 degrees, is for both triangles. So I'm going to actually add, so what I'm going to do is, I'm going to take angle A and add the new angle B and the new angle C, because the second triangle will have a different angle B and C. So if I fill this information in, angle A for both is 30 degrees. If there's a second triangle, angle B is 162.54 degrees. And now I have a way to see what angle C would be for the second triangle. So I think this is 30 plus this is 192.54. So that's what the new angle C is going to be, and look what it ends up being. Negative 12.54. Well, we can't have a negative angle for these triangles. So therefore, this tells me actually there is no second triangle. Now the crazy thing is, when I found the first triangle, at this point, I don't know if there's a second triangle or not. And the only way you can determine that is to go ahead and go through these steps. Now at this point, if this new angle C would have been a positive angle, then you would have had a second triangle. But if you get a negative angle for the new angle C, then that says there's no second triangle. So it's almost like you had to do this work just to see what's going on, and as it turns out, there was no second triangle.